Our sun is a fascinating star, a glowing sphere of hot plasma at the center of our solar system. It's not just a giant ball of burning gas, it's a dynamic powerhouse that influences everything in our solar system. The sun is a complex object with its own rhythm and cycles, constantly changing and evolving. One of the most intriguing phenomena is the periodic flip of the sun's magnetic field, a process that occurs roughly every 11 years. Imagine a giant magnet, flipping its poles every 11 years, that's our sun. This magnetic flip is a key part of the solar cycle. This flip is not instantaneous, it's a gradual process that unfolds over time, taking several months to complete. As the magnetic field reverses, the sun enters a period of heightened activity known as solar maximum, characterized by increased solar flares and sunspots. This increased activity can have significant effects on Earth, including beautiful auroras and disruptions to satellite communications. Understanding the sun's magnetic flip helps scientists predict space weather and protect our technology-dependent society. The sun's magnetic flip is part of a larger cycle known as the solar cycle. This fascinating phenomenon is a key aspect of our star's behavior. This cycle, averaging about 11 years, is like the sun's heartbeat, a rhythmic pattern that dictates the solar activity we observe from Earth. It consists of periods of relative calm, known as solar minimum, and bursts of intense activity, referred to as solar maximum. During solar maximum, the sun is particularly dynamic. We track this cycle by observing sunspots, which are dark patches on the sun's surface. These sunspots are indicators of areas with intense magnetic activity. More sunspots mean a more active sun, leading us towards solar maximum. This phase is marked by numerous solar flares and coronal mass ejections, which can have significant effects on space weather and even impact Earth. Solar maximum is a time of intense solar activity. Sunspots proliferate across the sun's surface, crackling with energy. Solar flares, sudden bursts of energy, erupt from these sunspots, releasing tremendous amounts of radiation. Sometimes these flares are accompanied by coronal mass ejections, or CMEs, which are massive bursts of solar wind and magnetic fields. Imagine billions of tons of plasma hurtling through space at incredible speeds. While the sun is millions of miles away, its activity during solar maximum can significantly impact Earth. The sun, our closest star, is a massive ball of burning gases, primarily hydrogen and helium, undergoing nuclear fusion at its core. This process releases an immense amount of energy, some of which reaches Earth in the form of light and heat, essential for life. The beautiful auroras, the northern and southern lights, become more frequent and vibrant due to the interaction of charged particles from the sun with Earth's atmosphere. These particles are carried by the solar wind, a stream of charged particles released from the upper atmosphere of the sun, known as the corona. When these particles collide with Earth's magnetic field, they create stunning light displays in the polar regions. However, this increased solar activity can also disrupt our technology. Solar flares and coronal mass ejections can send powerful bursts of energy and particles toward Earth, which can interfere with satellite operations, GPS systems, and even aviation routes. Imagine communication disruptions, satellite malfunctions, and even power grid failures. These events can have widespread consequences, affecting everything from daily communications to national security. Power grids are particularly vulnerable, as geomagnetic storms induced by solar activity can cause voltage instability and transformer damage. That's why monitoring the sun and understanding its cycles is crucial for safeguarding our technological infrastructure and preparing for potential disruptions. Scientists use a variety of tools, including solar observatories and space-based instruments, to study solar activity and predict space weather events. As we venture further into space, understanding and predicting solar weather will become even more critical for the safety of our astronauts and spacecraft. Missions to the Moon, Mars, and beyond will rely on accurate space weather forecasts to protect both human and robotic explorers from the potentially harmful effects of solar radiation.